Alright, in this episode we're going to do part 2. We just finished off with rows 1 and 2 orbital notations, and we're going to continue on. We're going to take a look at some row 3 things, and I'm going to introduce you to the noble gas notation. I got the periodic table up here. So we have just finished off neon, which is right over here on this side. We're going to go down to row 3. We're going to start with sodium. We've just filled the 2p block. And so now we're in row 3, principal quantum number 3, and we're going to start filling up 3s. And then when we get over here to aluminum, we will be starting in the p block, and that's also in row p. Now my intention is to not do all of these. I want to skip around and hit some high points, and then get down to eventually talking about potassium. But I will introduce you to a shorthand notation called noble gas notation. So if we start this, we are going to be atomic number 11, and we have sodium. And in the past, if you saw, we would just recopy everything we had for neon, and we would begin anew. So we would have 1s2, 2s2, 2p6, and you can see eventually that gets to be extremely long. And so we want to figure out, well, is there a shorter way to do that? And there is, and it's called noble gas notation. In noble gas notation, we are allowed to use the noble gas from the previous period. So noble gas from our previous period was neon, and for all of row 3 I can use neon as a shortcut. How do we do that? You simply place neon in brackets, symbol Ne I mean, and what this is telling you is that this accounts for the first 10 electrons, and it actually stands for all of this stuff right here. So the neon in brackets stands for all of that. So I don't have to record that. So now all I do is record new things. Well, what's our new thing we have to add? Here's sodium, and I need to add row 3, S block. And so now I write principal quantum number 3. S has one orientation. Neon is done. Piece of cake. If I go to count those up, I just count neon. That stands for 10 electrons. And then I've got the one more electron right here for a total of 11, and that equals the atomic number. All right, let's continue on with atomic number 12, and then we're going to do some skipping. We have magnesium, symbol Ne in brackets, still in row 3, still in S block, so neon looks like that. Now when we get to 13, this is aluminum, and again we can use neon in brackets, stands for the first 10 electrons. Shell 3 has been filled up, and now I start adding p electrons because it is the first element in row 3 p block. And remember, every time you switch orbitals, so we went from S, we're going into P's, you always write down the shell you're filling, shell 3, P's. Some people like to go in here and call this PX, and this is PY, and this is PZ. I don't necessarily stress that, just as long as you know they're P electrons. I don't need to go into the specific orientations of them. And we're going to fill up our first electron, up arrow. Now we can see then, if we're going to continue on, silicon, now's when I do my cheat. I'm going to erase this noise right here. And silicon, atomic number 14, would then have the orientation of this. The next element, phosphorus, looks like this. Remember, each orbital is only allowed to get one electron. So now we're up to phosphorus. So this would be atomic number 15, symbol P. And if you count up electrons, I have 1, 2, 3, 4, 5, plus 10 here for a grand total of 15. That should equal your atomic number. I'm going to back out of all that. After phosphorus, we start on sulfur. So sulfur will look like this. Next element, chlorine, will look like this. Next element, argon, will fill the 3 shell, and it looks like this. So now we're at atomic number 18, symbol AR, neon in brackets, 3s2, 3p6. And at this point then, I want to take a drawing, and I want you to see what the electron shell structure, or the Bohr model of the atom, looks like. And we'll do an atomic nucleus, and we'll surround it by some shells here. And since argon filled up 3 shells, we'll start there. I'll go back to the beginning here with hydrogen. Notice how hydrogen here filled up shell 1 with an s electron. Helium filled up shell 1 with another electron. So what I'll do here in red, we'll say red is s electrons. And so on shell 1, here's hydrogen and helium. So this is what helium structure is. Shells 2 and 3 are completely blank. Now I go back over to lithium. Lithium starts filling row 2 s block. Beryllium fills s block again. And so this is lithium, and this is beryllium. Now I always put the electrons opposite each other, but it doesn't really matter. It's just a matter of taste. Looks nice. Now when I get into the p block, because our next element after beryllium, boron, went into the p block, and so I got p electrons now to deal with, and then carbon adds a second, and then nitrogen a third. I'm going to color code those differently, and so we'll say green electrons are p, and so there's our boron and our carbon and our nitrogen, oxygen, and then fluorine, and then finally neon fills like this, so there's no electrons on the third shell. And then what we just got done here, we started with sodium, again with another s electron. So s electron in red, then magnesium, another s electron. And you see how the Bohr model now is coming straight from our model of the atom here, the electron configuration, at least orbital notation wise. And I can go ahead and start filling in the 6p electrons. And again, I just try to evenly distribute them, although they did badly on the left side there. So at this point, if I want to write the electron configuration, that's without orbital notation. Oops. I have 18 AR, neon in brackets, and then I just simply write 3s2, 2 electrons in s, and then I write 3p6. And so there's both different forms altogether. I'm going to continue on, make this a little bit of a longer video, and we're going to talk about row 4 next, and we can continue on. So we'll switch over. In row 4, you can see we drop down here to potassium. Potassium starts row 4, S block. And so we will start row 4, S block. Potassium is atomic number 19. So we'll do 19, potassium. Our noble gas now that we get to use is good old argon that we ended with last time because we're in the 4th row. So we can put AR in brackets. And it's filling shell 4. It's filling S block, and it's got 1 electron. Potassium, done. I can go on to number 20, calcium, and AR in brackets again because we used the noble gas from the previous period. 4s2. Up, down. Now things get a little tricky when we enter the next set of coordinates. I'm going to take a pause here because I want to bring up another document and I don't want to see you watch it load. Alright, what I wanted you to see here was a shell filling model, and you can see if we start down here at the bottom, we have started with 1s, and as we go up, we've done 2s, and 2p, then 3s, then 3p, and I just filled 4s for us with calcium. Now these electrons are filling in the lowest possible orbitals first, and by lowest I mean lowest in energy. And it turns out that so far the order has been exactly as we predict: 1s, 2s, 2p, 3s, 3p. Remember, shell 3 is allowed to have 3 different orientations. It has S, P, and D. Notice we filled 4s before we filled 3d because, as it turns out, 4s is lower in energy than 3d is. So after we finish filling 4s, which we did over here in calcium, if you look to your left, finished it off, we have a filled outer shell right here. And as you see, the next thing we start filling is 3D. Well, that makes a little bit of sense because if you take a look at the periodic table, scandium, right below the little hand there, that's the next element that we come to, and we notice it's in D block. And so we begin filling D's. You just have to remember this is filling row 3, D block. So I have a couple of slides here to show you how those things fill. So we'll bring this into view, and these little slides here show you the filling order. We'll talk about this one on the right first, right here. It's just a blank periodic table and tells you the shell filling order. So you can see up here at the top, we started with 1s, and then we went down to 2s, then we went to 2p, then we went to 3s, then we went to 3p. We just filled 4s, and now when we get to scandium, we're filling up 3d. That's our next thing we fill. And as we go to the end of 3d, then we start filling up 4p. When we get to the end of 4p, then we start filling up 5s, and then we start filling 4d, etc. Another way to do that is this chart here on the left. You notice how I have all the S's in one column, 1S, 2S, 3S, 4S, then I have all the P's, 2P, 3P, 4P, then all the D's, 3D, 4D, 5D, then all the F's, and I got these arrows going through them. The way you use this is you start at the tail of the arrow, you work your way to the head of the arrow, and you fill in order. So we filled up, start from the tail, we filled up 1S, get to the end, go to the tail of the next one. We fill up 3S, get to the head, go to the tail. We fill up 2P, then 3S, get to the tail. 3P, 4S, that's where we stopped at. Go to the tail of the next one. What do you fill up next? 3D. And after 3D, 4P. So let's take a look at some, very quickly, elements in row 4. Atomic number 21, scandium. I'm allowed to use argon in brackets. It fills up just like this. 4s, there's 2 electrons. Remember, argon stands for 18 electrons. So I got one more to fill in here because this is electron 19 and electron 20. So we filled up an orbital. So we write a 3. D's have 5 different orientations. Put a D, up electron. Now I'm going to go into cheat mode. Like I said, my intention is to go quickly here and get this timed off. So I'm going to erase this right here as what our symbol is, and I'm going to start with scandium. And now I'm going to keep on filling for each different electron. So scandium, titanium is next, atomic number 22. 23rd electron is vanadium. 24th electron is chromium. 25th electron is manganese. And you notice that manganese, all of the shells are half filled. Remember, each orbital gets 1 electron before I'm allowed to fill them. Then we go to iron. Iron gets our first down arrow, and I should stipulate it doesn't matter where the down arrow goes as long as each one gets a down arrow when they fill. They could go any line. It doesn't make any difference as far as I know. Cobalt, another down arrow. Nickel, another down arrow. Copper, another down arrow. And lastly, we get the zinc, which has a filled shell. Now, there might be some purists out there that notice that one of those wasn't exactly right, and this video isn't to highlight any of the anomalies on the periodic table, but just to provide the initial base pattern. When I did copper, I know it's not correct, but let's just follow the pattern at this point, and we look at anomalies later. So I've just filled up 3D. What comes after 3D? Well, I'm right here on 3D. Next comes 4P, and I start filling it. So I've just changed my orbitals. So we'll do a change of color as soon as I figure out how. There we go. Change my color up, and we'll do orange. And now I start filling shell 4. I'm in P block. Right after zinc is gallium, up arrow. Right after gallium is atomic number 32, germanium, up arrow. Right after germanium is arsenic, up arrow. Right after arsenic is selenium, down arrow. Right after selenium, atomic number 35, bromine, down arrow. And finally, we get to our noble gas, krypton, and it also has a down arrow as well. Electron configuration for krypton, Kr, Ar in brackets, 4, there's 2 electrons in S. there are 10 electrons in D, and there are 6 electrons in shell 4 P block. Now, some purists would say, well, you're supposed to write it as 3D10, 4S2, 4P6. And yeah, some books like it so that the highest principal quantum number comes last. I like to write it in the order that it fills myself because it's just a little bit simpler to do as you're doing it. Either way, it's the same thing. All right, hopefully that's a good review. Thank you for your time, and I hope this helps in your reviews. Thank you.